Hey guys, not the same as being in St. Anne's in room 141, but here we are. While I certainly miss seeing you guys in the classroom, can't even remember what Neil looks like, and wondering if Mark has mastered A through Z in less the world record, I'm going to try doing lessons online. I can find lots of stuff online, but they explain it a little bit differently than I do. And so when you look at my solutions, maybe my solutions don't make as much sense. So, one sec.
Oh, you have to do a cartwheel.
No, cartwheel.
Yeah, cartwheel. Cartwheel.
And here is how I'm taping the lessons. So, on that note, let's get started. Okay, I think we're good to go. So this is common factoring, and this is 4.1 in your textbook. I assigned this and put some videos for you to watch, but I just want to make sure that we go through a few of the examples before we move on to 4.3. So, for example, question number 4 says 3x squared minus 9x plus 12. So, for every single question in this unit, the very first thing you have to ask yourself is, can I pull a common factor out? It's the basic step, but the step that you always have to check for. So what I'm looking at is I'm looking at all three terms and I'm saying, okay, what is the greatest common multiple? I know that I can pull a factor of 3 out of 9. I can also pull a factor of 3 out of 12. In one of the videos that I posted from Khan Academy, which is how I would show it, I would actually rewrite this as a factor of 3. So 3 is the same as 3 times 1. And I'm not going to do anything with the x squareds right now because there's no x variable there, so there's no common factor. So it's 3 times 1x squared minus 3 times 3x plus 3 times 4. So if you take a look at this line of the equation, it is exactly the same as the one above, but all I'm doing is I'm rewriting the numbers as factors of 3. So what I can see then is, thank you, religion department. I'm going to grab a different color marker here. Let's go purple. Is that I have a common factor of 3 in each of these terms. That means that I can pull that factor of 3 out in front. And what I'm left with is what's left over. If I take a factor of 3, I'm left with x squared. I mean, technically I can put my invisible 1 in there, but I don't need to. Over here, if I pull a factor of 3 out, what am I left with? Minus 3x. And over here, if I pull a factor of 3 out, I'm left with plus 4. So that's the basics of common factoring. You're taking a look at pulling a common factor out of all of the terms. Remembering that anytime, so if I wrote this properly, I would say that that's 3x squared minus 3x plus 4. The idea is that if I actually use that distributive property and I multiply my girls and neighbors are at the window. If I actually multiply that 3 back into the equation, I should get what I started with. So let's just see if that's true. So I have 3 times x squared, which equals 3x squared, 3 times minus 3, which is minus 9x, positive 3 times positive 4, which is plus 12. And if you take a look at it, these two things are equal. That means that I've actually common factored, or I've factored correctly. Remembering that I need to put equal signs everywhere to make that communication mark the best that it can be. Okay, so that's a basic for common factoring. I'm going to do maybe 4 or 5 examples with that, and then I'm going to move on to section 4.2 and 4.3 because they're the same thing. So let's take a look at something like this. So this would be question 4b. These questions are coming from page 203. So 4b says, okay, you have 5x squared plus 3x. So I take a quick look at the numbers and I say, okay, well, I can't write 3 in any way as a factor of 5, so I can't pull a number out. But if I take a look at this, I can write x as x times x. And then if I take a look at these two terms, I see the only thing that's common to them is the x. They both have an x. This one has x times x. This only has 1x. So the most I can pull out is the lowest order or the lowest exponent. So I could pull an x out in front. And when I pull that x out in front, what am I left with? I'm left with 5x plus 3. So my answer for that is 5x plus 3. And my quick check would be to multiply it back in, and you can just do this in your head. I'm showing you on paper. When you multiply it back in, x times 5x equals 5x squared plus 3x, which is what I started with, right? Because the fact that those two things are equal means that that is the correct way to factor that initial question. Okay, let's do two more of these. Let's take a look at C. I have x squared y minus xy squared. Now, when you first start doing these, you might want to write them out, but after you've done them a couple times, you probably won't do this. You'll be able to do it in your head, but let's write it out. X squared is the same as x times y minus x times y times y. So I take a look at these and I say this has two x's, this has one. The greatest amount I can pull out is an x and an x. This has one y, this has two y's. I can pull out a y here and a y here. That means that the common factor I'm going to pull out is going to be xy. What am I left with after I pull out xy? Well, I'm left with this x minus, they've been pulled out, they've been factored, they've been pulled out in front, minus y. And it just in my head, let's take a look at it when we use a distributive property and I multiply those, I get x squared y minus xy squared. So I know that that is the correct answer. Okay, and for D is a little bit trickier. We'll run into this in some exercises later. There we go. So I'm going to do a little timeout. Before I start this question, I'm going to do a little timeout. If I said to you I had 3 happy face plus 5 happy face, and I said to you, what is multiplied? What is the common factor? The only thing that would be the same to those would be happy face. Happy face can be a factor. I could pull a happy face out, and what I would be left with, it's about happy face, I'd be left with 3 plus 5. Okay? It doesn't matter what the actual variable that you're pulling out in front is, as long as it's exactly the same. So if you look at this, this is x minus 1 and this is x minus 1. They're exactly the same. Therefore, I can pull x minus 1, that entire bracket, out as a factor because it's common to both of these terms. So when I pull out x minus 1, what am I left with? I'm left with 4x plus 3. And that's how you common factor that expression. Okay, I'm going to stop there, and then we'll move on. Yeah, how many times have I ever wished I'd asked Santa for a home whiteboard? Never, but now I wish I had one. Okay, so I'm still on page 203, and I'm looking at question number 9. I'm not sure these markers that I borrowed are so new. Okay, so let's take a look at 9a together. I have dc squared minus 2acd plus 3a squared d. Okay, so first of all, I take a look at the numbers out in front, the coefficients, and I have a 1, a 2, and a 3. So I can't pull a number out in front. So now I'm just going to take a look at those variables. This has a d term, this has a d term, this has a d term. So I should, this is to the power of 1, power of 1, power of 1. So in my head, I should be able to pull a d out. If I take a look at the c term, I've got a c squared, a c, and no c. Because there is no c here, I can't pull it out in front. Every single one of these would have had to have at least one c in order for it to be a common factor. So I can't pull a variable of c out. The only other variable that we have is a. I see an a here and a squared, but there's no a here, so I can't pull that out. The only variable or the only common factor to each of these terms is d. It's the only thing that I can pull out in front. So if I pull a d out in front, so I'm going to pull a d, and a d, right? So those are that's my common factor. If I get rid of those, what am I left with? c squared minus 2ac plus 3a squared. That's the answer. Okay, and again, if I use that distributive property and I multiply them back in, I should get the equation that I started with. Again, this is where I would ask if you had any questions, but I can't do that. Let's take a look at 9b. I have negative 10a squared c plus 20 ac minus 5ac cubed. Okay, so first I'm going to look at the numbers 10, 20, and 5. I try to figure out what the greatest common factor of those are. It happens to be 5. So let's just rewrite this. And I'm not saying that you would need to do this, but when you first start factoring, you might want to do it. Let's rewrite this as negative 5 times 2 a times c. So that's 10a squared c plus 5 times 4 times a times c minus 5a c times c times c. Here's my daughter again. Okay, so I take a look at this. I see that I can pull out the greatest common factor of 5. So 5 is a common factor. And now let's take a look at the variables. A, 1a, 1a. So the largest amount that I can take out from each of them would be 1a. So I'm going to pull out an a. I have 1c, 1c, and 3c's. The most I can take out is 1c, because otherwise I would run out. That means that if I pull all of these out in front, I have to be pulling the exact same thing out in front for all of them. I would be pulling out a 5ac. If I pull out a 5ac, 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 what am I left with? Well, I'm left with negative 2a, so there's my negative 2a plus 4 minus c times c, which is c squared. So I have just common factored that. Okay, again, if I use a distributive property and I multiply that all back in, I should get that answer, which I would. Okay, so that's 9b. Let's skip to 9d because I'm getting bored. 2a squared c to the 4th minus 4a cubed c cubed plus 6a to the 4th. Oops, that's supposed to be a c squared. So I take a look at my numbers first. 2, 4, 6. The largest number I can pull out of there is 2. Let's just, I'm not, again, you don't need to do this, but one, 2, 3, 4, 5, 6 plus 3 times 2, 1, 2, 3, 4, 5, 6. Okay, so what can I take out? I can take out a 2 from each of these. I've got 2 A's, 3 A's, and 4 A's, so I can pull out 2 A's. And I've got 4 C's, 3 C's, and 2 C's, so I can pull out a maximum of 2 C's from each thing. That means I'm pulling out 2a squared c squared. I guess I should say I'm factoring out a squared c squared. Let's get rid of those and see what I have left over. I get rid of an a squared and a c squared, 2a squared c squared, 2a squared c squared. And what am I left with? I'm left with 1 times c squared minus 2 times ac plus 3a squared. Stick in my equal signs and we're good to go. Okay, I'm going to stop there because I think that's enough to get you going on 4.1. I am going to, yep, the cat's sleeping. I'm going to push stop and then we're going to move on to 4.2, which is a couple extra steps, but definitely probably the most important technique of the unit. So here's Mr. Tony. Oh, the cat that will probably fall asleep.
Baby Yoda.